classifications of some optic fiber. For that, some base thing we should know, like again I will repeat. So in optic fiber, there is basically three layers are there. One is core, cladding, and a protecting sheet. Okay, the inner one, red color one is the core, and outer yellow color part is the cladding. Outer orange color part is the protecting sheet. So whereas both the orange color and the yellow color is the protective medium only for this core. So if you see this thing, this material in your lab, it will be like a glassy material, glass and plastic. Okay, so mostly this type of wire should not bite. So most of the electrician, if you see, if they not have any cutter, they will usually bite it and they will work. But especially for this optic fiber, comparatively to other wires, it is very thin only. But even then, it is we have to be take cautious while we are while cutting. Okay, it should not lethargically not cut with your teeth. Okay, so some glassy substances, if went into your mouth, it will get full septic, and it will affect your internal organs also. So we have to be take care when the repairmans have doing. Okay, and we have come up with these thing classifications of optical fiber that we have look on with the step index fiber and graded index fiber. And step index fiber, yeah, you can see this part we have completed. So I'm going fast. This inner core provides the step like this. Outer you can see it like a step, a normal step. A step means what we have one by one increment in a tapered way, so that we are get into the some top floor. Okay, like that here also some step index graded and the graded index. What is step index means? You it will be incrementally go or propagate the signal according to that layer. Okay, so that is the meaning of it. And this typical step index single mode has the core diameter of 2 to 10 micrometer. It will be very very thin as like of the human hair. Okay, in that medium only that light signal will get propagate. So as I told already, so now I am speaking through how? Through the laptop mic, or else my webcam mic, or else through my headphone mic. Okay. So when my signal is getting to the system, it will be initially in electrical format, and it is going to the my laptop. It have some processing, and it may be convert into system understandable level. So like that, in optic fiber, it have some conversion to flow the signal in the optic fiber. So in optic fiber, it only supports with the light. Okay, it only supports with the light. So that signal only it will support, and it will be get into it, and we will get we will get what yeah, we will get a quicker bandwidth signal for that cases. And here you can see they have single mode and multi mode. In single mode only one core medium will be there, whereas multi mode multi core medium will be there. So this formula we have seen. At the end I will give one problem. Okay, so that problem please make a note, and that will be maybe ask in your even then in your you have my MCQ. Okay, just answer you have to solve by using the formulas. Graded index fiber, it does not have the constant refractive index. You can see sine form, sine signal is going inside to that medium, sinusoidal. But you can see so it will be like a graded. Graded means first the amplitude is high, somewhat come, it is gradually decreasing. After that, it will come to the along the axis also. The signal will comes along to the axis. So this is the property of your graded index fiber, and some formulas you can see like delta refractive index difference and alpha is nothing but profile parameter. So by using that, they have given some formulas. Just remember alone, that much not important. Okay, so this is the profile for the single indexed optic fiber. Okay, so based on the index values changes like alpha is equal to 0, alpha equal to 1, alpha equal to 2, alpha equal to infinity. Okay, so alpha equal to 0 means it is along axis, alpha equal to 1 means it is like a triangular, and alpha is equal to 3 means it is yeah. So based on that, you can see how the spectrum under the top it will be get varied. So this is the what, and this entire thing is called as the total internal reflection loss. Okay, and sometimes they will ask this type of graded index, and that is a single step indexed fiber and a multi indexed fiber can be applied for the intermodal dispersion, and it can also have high numerical aperture and a high bandwidth. So this is the advantages for this system. And for multi-mode graded index fiber, there are many core material will be there. It cannot be predicted. So each of the company is fabricated for to improve the intensity level of the signal. Okay, so they may come with the basic thing. One is the in order to avoid the absorption loss, the high purity core under the cladding materials. Uh, yeah, cladding materials are selected. The outer layer may be okay. The outer layer. Uh, 1 minute. The outer layer may be of the improved rigidity to resist the bending. That means, as I told in already, even if you bend at any case, it won't break. Okay, it have such a resistive property. Outer layer has the different refractive index. Okay. And fourthly, it has the thickness of cladding will be normally very thin, and it is used only as a barrier to prevent the impurities from the outer layer to migrate into the core system. Okay, can see the picture. Okay, can see this picture. This picture, students, if any of them waiting outside or any doubts or clarification, at any point of time you can ask. Okay, so it should be some interactions maybe. Otherwise, at the end of the session, you can ask. Okay. So this is the 3D image I have provided. The core. Okay, please see the core. Inside core only the signal is going. You can see it is mentioned in an orange color. When the beam of light is at the starting point, you can see look like a conical. Its diameter may be differing. Okay, according to the differing, its pulse you can see at the outcome. Okay, you can see the pulse at the outcome. So in first case, you have the sharper conical beam is passing over to this thing. We are getting the less pulse, that is a narrow pulse beam we are getting. When the conical beam is very broader, we are getting the broader pulse. And when we giving this type of pulse, we are getting the something like a parabola. Something like a parabola. So this is the different patterns of the optic fiber. Yeah, with this base concept only, we are going for the another concept called ray theory. So this concept you have studied in your 12th standard subject physics itself. Actually, this concept evolved from Scattering's Raman's principle. Raman scattering principle. Raman is a one scientist. Actually, what he did is that he has and he has one big stone, I think. Yeah, big stone, and another strong stone is there. Some big brick, that is normal brick. You know how it will be, like a rectangular one, and strong stone. Stone means we cannot break in normal hand. Okay, just imagine the stone and the brick. Okay, when he throw that brick to that stone, what happens is that brick is very big size. Sorry, brick is very small size somewhat, but the stone is very very big. Okay, so when he put on that, it will hit on the hit onto the that stone, and we are providing the that is what happened. It will be strike on that stone, and it will scatter. Some small particle will get scattered. Why means it will be strike on that big one. And similar, the signal also like that. When the signal is coming from any of the original point or incident point, there in the medium there are lot of disturbances are there. Like due to nature, some different voice will come, and due to winter or rainy time, heavy rains are flowing up, and thirdly, some big buildings are there, birds are flying. Okay, so many disturbance. Even we are sending this type of signal to any of them, there are a lot of disturbance will be there. So these things are overcome by using the newer technology, and then we are retrieving those signals. Okay, so you can see this diagram. This diagram, they have mentioned it of instant wave from any of the source. Okay, then after it will be strike on one medium. You can see when it strike on that medium, it will be go to the another. Actually, the medium here, it is the normal line. This is the medium. Okay, you can see medium line. Below one is the somewhat green thing has been given. Top is white. So the normal line is in dot. Okay, so when it strike on this medium and it goes to the next. Okay, next, but it will comes down. This is nothing but your refracted wave. Okay, so this is the one of the best example of it when the light is passed through any of the prism. Okay, so the seven colors that with GR you will tell in simple rainbow colors. Okay, so that you can see all. Okay, by when you pass to any of the prism, I think you may experience on this. Um, okay, this is the normal ray theory. For ray theory, we should know about some base concept of nature of light, ray optics, refractive index, Snell's law, total internal reflection loss, acceptance angle, numerical aperture, optical fiber structure. So actually, for this optic concept, you can have one book called as Kaiser book, and then in microwave, that is Allen book will be there, that I will upload in the Google Classroom. So during a leisure time, you can look into the e-books also. Since during this pandemic time, you not have even touch with the textbook. Since you not have opportunity to go with the library, not have touch with the e-books. At least you can touch with the e-books, can get aware what is the textbook it is. Uh, okay, so let me go with the what is meant by uh, the nature of light. What is the nature of light? The ray optics. You can see there are four basic terminologies are the ray optics. The propagation of the light rays through a simple optical communication and component is called as the ray optics. Similarly, the wave optics propagates of light waves through optical communication uh, and systems. Next one is the electromagnetic optics. Okay. In terms of the electric and magnetic field. Okay. The last one is the quantum optics. The quantum optics only what I'm saying is that when the signal is coming out from the antenna system, it will heavily radiates the signal in terms of photons. Okay, that photons cannot be seen through the naked eye. That is called as energy absorption or emission, which are characteristically quantum mechanical in nature and cannot be explained by the classical optics. Okay, example is laser, light emitting diode, photo, shortly diode. Okay, so this is the light of nature of light. How the light has been termed as a wave, rays, and photons. So actually, the light is the electromagnetic wave only. In a home, we are using the some lights, maybe a tube light or torch light, whatever light it is. Some beam of spectrum is going out. Okay, something radiates. Some energy is being dissipate. Okay, this is the input. And you can see the second term is the rays. The rays is a wave, nevertheless, travel along with the straight or enabling us to analyze the simple optical component and instrument in terms of geometric option. And a light is also called as photon, discrete particle uh, carrying the packet of energy and movement. So that means simply remember that the light is your input signal. Okay, the light is your input signal. It will be penetrate to your optic fiber, and it will propagate to the optic fiber, and we are get benefited of the signal conversation. And ray optics or geometric optics. You can see in ray optics and geometric optics are almost same, but here we are going to express in terms of wavelength. We already know the wavelength lambda is equal to C by F. That is for your antenna system. Okay. So, okay. You can see these two diagrams. Okay, you can see these two diagrams. These two diagrams, you can see uh, the green color has been given. It is a lens. It is a lens. So when the parallel waves are hit on the lens, it has been collimated to one point. Okay, collimated to one point. Whereas if you keep one mirror, it will be reflect back. That is your day-to-day life. We are seeing the mirror. Okay, according to our projection or according to our angle, it may be changed. Okay, so this property will be applicable for your optical fiber, which going to travel in the. Let me go with some base laws in this thing. Okay, so that is the light ray is a homogeneous medium or the straight line. The law of reflection. Okay, so the law of reflection. Okay, mm, in this base law, actually this particular reflection under the Snell's law concept I have explained. So the reflection is coming in the same medium. So what only here we are giving the condition as theta r equal to theta I. So where theta r is nothing but angle of reflection, where theta I is nothing but the angle of incidence. So this is occurring in the plane, normal plane, uniform normal plane. But when we talk about the refraction, okay, uh, okay. And Snell's law, I can say at the boundary between the two media of different refractive index, the reflected, okay, it will be related with the angle of refraction under the angle of incidence. So the formula will be given like this: n1 sine theta 1 equal to n2 sine theta 2. Okay, so this is the Snell's law procedure. So it has been divided into a four quadrant. So one medium is a glass, another medium is the air. So it can be called as the core cladding relation or the core cladding layer. Okay, so okay, so since I am not sorry, already I have given the sufficient explanation on this. I'm not going to give much on this. Basically, your core material will be non conducting medium. So it is literally called as insulator, or else technically called as dielectric. Okay, so refractive index in any dielectric medium, the speed of light becomes v is equal to c by n, where c is nothing but velocity of light and n is nothing but the okay. Okay. So in this regards, you can see for air and glass. Sometimes they will ask question for air and glass. V is nothing but what the speed of the light is approximately equal to velocity of light, and also the refractive index then is equal to 1. And then the refractive index of water is 1.33. And then for different medias they have given silica is 1.45 and the glasses 1.48. Yeah. So here the list of values has been given for different medias. Just look into it. This is for your kind reference. Okay. And what is meant by the critical angle? Now come up with some performance measures like critical angle, total internal reflection loss, and then light ray guiding conditions. Yeah, three things are different. Uh, the total internal reflection, yeah. So if the mental of okay, the total internal 1 minute. Let me go with one by one. So where n1 is nothing but what refractive index. That medium should be high, even if it is a small. If the core material is very small, automatically the n1, that is refractive index of the core, will be increases. So what only n2 is greater than the n1. And also you can see the another condition when the angle of refraction theta 2 equal to 90 degree, then okay. And please see, by using this thing, we can find enormous thing of calculations, but that is not needed right now. Just remember the formula and just see some problem related to it. Okay, so maybe that may be really useful. Yeah, the next one is the lightweight guiding conditions. So when the light ray satisfies the total internal reflection loss at the interface of the higher refractive index of core. Already we know that inside the core, the higher refractive index will be there. Rover refractive index cladding can be guided along the optical fiber. So the cladding material, the signal will not go, but heat energy will be there. Okay, heat energy will be there. So then this condition is being. So you can see one formulas. Okay, so I hope you have noted. I will go to the next slide. Optical fiber structure. Okay, so I have drawn by using the geometry with the three layers like this. Only optical fiber structure will be there. A typical bare fiber contain of the core cladding and the polymer jacket. Okay, so it is also called as the buffer coating. The polymer coating is the first line of the mechanical production, and the coating is also reduce the and also you can say coating also. So some I can say another case has been given. The coating also reduces the internal reflections at the cladding. So the light is also guided by the core. I give one best example for this for the second point. When an athlete is running over some 500 kilometer, is it energy level at the first initial point will be same at the 500 kilometer? Definitely not. So it will be gradually reduced. Similarly, here also the point will be there. Uh, then you can see the silica material. Silica material by using the silica material only, the that is what the core has been fabricated. Silica is the normal sandy material only. By using that sand only, they will develop a clay type of unit, and then they will mold. And further, some machines are there. Nowadays, they're not doing with their hand, so everything will be get automated quickly and okay. So I hope up to this part, the material part, again we will start into the next class. If you have any doubts or clarification,